Okay, hello everyone. Welcome here to the Java Champions Conference, right? So if you can see me, if you can hear me, if everything is good and fine, let us know in the chat, right? So we can start having a good conversation here. And we just want to make sure that everything is ready and set so we can bring our guests here to discuss with you, right? So without further ado, it looks like everything's okay, or maybe not. So, sometimes we have some glitches and that happens, right? So I just want to make sure everything's right and good. Um, and maybe it's not so good because actually, let me take a look. Let me see here if I can see. Okay, now I can see people coming up. All right. Okay. So now I see people arriving here. That's good. So if you can hear me, if you can see me, just say hello in the chat so we can talk. We can talk a little bit about here. Okay, Vincent. Hello, Java man. Vincent from France. Okay. So we all set to go. So without further ado, let me introduce here this amazing Java champion, right? So we're gonna have this very, very special Java champion, Grace Jensen. So let me bring Grace here. Hey, Grace, how you doing?
Hey, great to join you guys. Thanks so much for having me.
Yeah, so I can see here. So Michael is saying hello. Hey, Michael.
Hey.
Sebastian, hello from Germany. Garrett, let me put some of those names here, right? So Michael, and then Vincent from France, and then Sebastian from Germany. So hey, hello, Sebastian, and then Gary from Missouri, right? Okay, so Michael from Flemington, New Jersey. Awesome, man. That's
I feel like
great.
I need to visit more of these places. They sound great.
Yes, that's great too. Yes. So where are you right now, Grace?
I'm based in the UK in a town called Southampton. People only ever know it for the football club or because the Titanic sailed from here. So
All
one of
right.
two things.
Yes, so Southampton is one of my best friends, Simon Phipps. Used to
Yep.
be the chief open source officer at Sun and used to be my boss, right? So he lives in Southampton. So I've been there several times.
That's pretty cool.
Yeah. All right. So then I see here Paul from Vincent from Greece and Paul from Dublin. Okay, so that's great. So everything's working. For a second there, I thought that nothing was working. So that's all right. Okay. So without further ado, so guys, Grace Jensen is a Java champion, developer advocate at IBM. She is specialist on Java, open source, cloud technology, and she talks. She's very, very good also on driving diversity in our industry. So, and the topics we're going to talk about today is cloud native, but observability is one of the most important topics of this moment. So without further ado, with you, Grace Jensen.
Hey! Thanks so much, Bruno. I feel like it's always fun when Bruno hosts your session. Really appreciate it. So yeah, thanks for the introduction. For anyone I haven't met, hi, it's lovely to meet you guys, and it's great to hear that you're joining from all over the world today. Thanks for spending the time to come and join this conference today and listen to my session. I'm a developer advocate at IBM. I wasn't always. I actually did a biology degree and then switched to technical Java development. So it's been a bit of a roundabout journey for me, but I love to be able to sort of bring a different perspective to technology, bring some analogies in, try and make what can be kind of very abstract concepts a little bit more concrete. So hopefully I'm going to do that today with observability. We're going to take a look at sort of stepping through, looking through the looking glass, going through it to enable us to have effective observability for cloud native applications. So that's the topic today. I am going to go through sort of the whole presentation, and at the end, there's going to be a demo. I'm going to be utilizing our OpenABT labs. So if you do want to have a go with them yourself, you will be able to have a go at the same demo as me after the session today. So if hopefully I pique your interest during the session, you'll be able to follow up with it afterwards. If I don't get round to any questions, or if you feel you don't want to ask them in a public channel like this, then please do reach out to me on social media. I'm on LinkedIn and I'm on Twitter as well, or X. You'll find my handle is sort of at the bottom here with my name, so at Grace Jansen 27. That's my handle on Twitter. On LinkedIn, just search for Grace Jansen at IBM, and that should be me. And then feel free to message me on there. So without further ado, let's get started with the topic for today. So, why have I named this topic Through the Looking Glass? What does this really mean, and how does it relate to software? So, through the looking glass was a phrase that was coined by Lewis Carroll, who is the famous author of Alice in Wonderland, which you might be familiar with. Alice in Wonderland was actually, there was a sequel to this book that was called Alice's Adventures in Wonderland. That book was made into a film recently by Disney, which is called Alice Through the Looking Glass. So you might be familiar either with the book or with the recent movie, which you may have seen. But essentially in this book, Alice passes through essentially what's a mirror, or in old-fashioned terms, a looking glass, hence the name, over a fireplace, and she finds herself once again in this enchanted land of Wonderland. So it's this kind of analogy that we use, through the looking glass, of kind of stepping through a portal into this world that kind of seems familiar, but is a little bit off as well. It's a little bit unfamiliar and different to the world that we normally know. So it's kind of a portal or a gateway to this magical world so that we can see things that we wouldn't otherwise see. If you're not familiar with Alice in Wonderland, maybe you're not a literacy nerd, which is absolutely fair enough, not everyone is. Maybe you're not more of a movie buff. Can anyone recognize this still image and where this analogy might also be used in another movie? Anyone know what this is from, what movie? I can't see any comments yet in the channel. I'm having a look. Anything? No. Okay, it might help when I actually play it. So let me try and play, and then we can see. So this is actually from The Matrix. So actually, this is another sort of reference to this analogy of being able to step through essentially a mirrored surface into this unusual and magical world. And actually, they refer back in The Matrix to Alice in Wonderland several times, making this sort of connection between the two movies or the two stories. So in the beginning of the movie, Neo gets woken up by his computer, sending him a message saying, "Follow the white rabbit," and he's following the lady with the white rabbit tattoo. There's also this phrase of, you take the blue pill, the story ends, you wake up in your bed and believe whatever you want to believe. You take the red pill and you stay in Wonderland, and I show you how deep the rabbit hole goes. So several references back to that analogy originally made in Lewis Carroll's novel. So really what I'm trying to get at here with this title of this talk and this analogy is we want to be building an effective looking glass or mirror or portal or gateway so that we can look through into this sort of convoluted and sometimes complex world of distributed cloud native applications and be able to understand what's happening within that environment, how are applications behaving in real time, and whether there's anything we need to do to fix potential bottlenecks or problems so that we can understand that world. So this is what we're trying to achieve in this presentation. How do we make that effective looking glass to achieve effective observability? And so that's why I've kind of used this analogy, hopefully to make it a bit more concrete so we can kind of imagine that as we go along. So first things first, what do we mean by observability? Because this is a phrase that can often mean different things by different people. It's quite broad. So I figured if we get all on the same page right now, then we can go ahead with this presentation, all knowing what we're trying to achieve. So in general, this is sort of a definition I took from multiple different sources. Essentially, if we're looking at the general definition of this term, it's about understanding the internal state of perhaps a complex system based only on its external outputs. So it's all about being able to provide these sort of highly granular insights into the behaviors of systems along with rich context based on these outputs. However, this is kind of very generic and it doesn't really help us understand, okay, but what does that mean to me as a Java developer? What am I trying to do? How do I know what I should be outputting? How do I know what I should be understanding in terms of the internal state? So what I did is I went and had a look at various different definitions by vendors, by sort of open source foundations, and by experts in the field, looking at, okay, what does this mean specifically for us in the world of IT and specifically cloud computing? And we came up with this definition. So observability is about utilizing software tools and practices for aggregating, correlating, and analyzing a steady stream of performance data, normally from a distributed application, because we're working in the cloud often here. It includes things like hardware and network. But effectively, what we're trying to do is utilize the aggregating, correlating, analyzing to be able to monitor, troubleshoot, and debug both the application and the network. So it's these three things on either side that we're trying to achieve with observability: aggregating, correlating, and analyzing to be able to monitor, troubleshoot, and debug, hence the highlighted parts here. So now that we understand what we're trying to achieve, these three things on either side, how do we actually go about being able to do this in our own applications? So for this, I'm going to first take a look at the theory of, okay, how do we theoretically enable observability? Then I'm going to go into the practicality of looking at some open source specifications and frameworks to be able to understand how we take that theory and actually apply it in practice. And then I'll show a demo using a sample application to showcase how easy that can be to enable in your own applications using different forms of implementation of these open source specifications. So first things first, the theory. When it comes to implementing observability, it's actually conceptually fairly simple. To enable observability, there are three key steps. The first of which is instrumentation. So we need to be able to instrument our systems and our applications to be able to collect relevant data, because without the data, there's nothing really to understand. We need to first enable our applications to produce this data so that we can then analyze and sort of understand the trends within that data to understand what's going on. So this data can include things like metrics, traces, logs, and lots of other data that we can include there. But essentially, any relevant data, we need to ensure we're instrumenting that within our systems and applications. Step two is once we've got that data, we need to be able to send it somewhere to a separate external system that can then store and analyze it. So going back to our definition, we're talking about that aggregating, correlating step, analyzing, those three behaviors that we wanted to see when it comes to cloud computing. So you might already be utilizing tools for this. So for example, you could export the data via microprofile telemetry. If you're not familiar with microprofile, I'll be introducing it later in this presentation, so keep your eyes peeled for that. You can also utilize tools like Jaeger, Zipkin, or the OTel collector, which we'll also be looking at later. So these are tools that can enable you to really sort of effectively send that data to a separate external system, store and analyze it. And the third final step is, okay, once we've got that somewhere, we can analyze it. It's all well and good having analysis of all these numbers, but often tons and tons and tons of numbers in a massive spreadsheet doesn't really help us in a quick snapshot understand what's going on in our application. It can take a bit of understanding. And so to make this much simpler, it's great if we can be able to provide visualizations and the ability to have sort of things like query capability, very key insights into what our system's doing as a whole. And so this is the third step, is really providing us with the ability to have the power of observability by understanding in just a quick snapshot what's going on in our application that I need to know about as a developer or maybe as an ops person as well. So for this final step, there are, again, another set of tools that you could utilize. That goes from open source all the way through to proprietary. There's lots of different options here. Some of the tools you may already have heard of for this are things like Prometheus, for things like systems monitoring and alerting, Grafana, an open source analytics and interactive visualization, Kibana, for example, which provides users with tools for exploring, visualizing, and building dashboards on top of log data. So if you're using Elasticsearch, for example, that might be a great tool to use. So for steps 2 and 3, so sending that data for storage and analyzing and providing those visualizations, there are already tools available, both in the open source and proprietary, things like Instana, for example, that can enable you to achieve these. But it's this first step, this instrumentation step, that I really want to focus on in today's presentation. Because as I mentioned before, if we don't instrument, then there's not really much point in steps 2 and 3. So how do we effectively instrument our application for enabling sort of this portal, this mirror into effective observability in the cloud? And when it comes to instrumentation, to make a system observable, we have 3 key pillars. So these 3 key pillars, which are visualized here as these pillars of this sort of temple of observability, is logs, metrics, and distributed traces. While plainly having access to these doesn't necessarily make a system more observable, they're very powerful tools that, if we understand them well and utilize them well, can then unlock the ability to be able to enable us to build better systems and to improve our own applications and systems over time. Now, that's not to say these are the only pillars that you could use to enable effective observability, but they are the key pillars in some of the open source technologies we'll be taking a look at later. Other pillars you might want to take a look at, and it is hoped that with time, these will be introduced to the open source specifications and standards like OpenTelemetry. So these are other types of telemetry data, like, for example, end user monitoring and profiling. So end user monitoring being enabling organizations to gain real-time visibility into the user experience. So we might be, for example, tracking the path of a single request and gaining insights into every interaction it has with every service along the way. Profiling, on the other hand, offers us the chance to be able to understand where our code spends its time and its hardware resources. So things like memory and CPU, how much does it consume and why, right down to the individual line number. So it can enable us to be able to better understand resource usage as our applications are being used. So both of these are really helpful. And as I said, hopefully in time, they'll be integrated into these open source standards. But for just now, we're just going to focus on these three main key pillars. So first one of those is logs. I'm not going to spend too much time on this because I'm aware that many of you are probably already utilizing logs. But really, although logs are found almost everywhere in software, and they've been really heavily relied upon by developers and operators to help understand system behavior. Unfortunately, logs aren't extremely useful when it comes to tracking code execution, because what they typically lack is contextual information. So for example, where they were called from. So they become far more useful when they're used in conjunction with some of the other data that we're going to be collecting. But essentially a log is a timestamped message, normally emitted by a service, that contains higher level information. Things like errors, warnings, and they typically happen at a set point in time. They're not really sort of a piece of data that can tell us a lot about sort of the overall health of an application over time. We just see those particular events occurring at those time-stamped sort of times. So that's logs. Again, a very useful tool, but it doesn't provide everything we need. So then we move on to metrics, that second pillar. So metrics are much more malleable to mathematical, probabilistic, and statistical transformations. So it's all about aggregating numerical data, and it allows us to do things like sampling, aggregation, summarization, and correlation. So really understanding how our application is behaving over a period of time. It can include things like system error rate, CPU utilization, request rates. It's a very broad definition here of what we count as metrics. Metrics are a great tool to be able to utilize, to be able to, again, see those trends over time, see that correlation over time. However, there are limitations to this as well. Now, if you wanted to introduce metrics, if you haven't already, into your application, then there's a fantastic API from the microprofile community that you can make use of. As I said, I was going to introduce this just in case others haven't heard of it. So here is that introduction. So perk your ears up if you've not come across this open source community before. So this really is a community-driven specification that offers important APIs if you're looking to develop cloud-native, say maybe microservices in Java for the cloud, designed for the cloud. So it offers some APIs that are shared with Jakarta EE, another community-driven open source specification. So you'll notice a lot of the bottom row here is shared with Jakarta EE, things like JSONB, JSONP, CDI, JAX-RS. So many of these are shared, but they also offer additional on top of those shared ones. And one of the ones I wanted to point out, particularly for this bit, is that metrics API. So that offers really a standard specification to allow you to have metrics shared from your application to really gather that numerical data. The nice thing about microprofile is that this specification is enabled in multiple different implementations. So you don't have that vendor lock-in that you might have with alternative runtimes, as an example. So the nice thing is that microprofile, you can see lots of different runtimes here that are compatible with the different versions of microprofile. And this list is constantly being updated. So do check out the microprofile website if you want to know which ones are running on the latest microprofile specs. As I mentioned, microprofile metrics, really handy API for this particular pillar of observability. This specification aims at providing a unified way for microprofile servers to export that monitoring data. So really about unifying, providing that standard for Java applications. So a fantastic one to check out if you haven't already. We're going to be using some of the Open Liberty guides at the end of this presentation for the demo. And we do have a guide on microprofile metrics. So if you're not sure, you don't know where to start, it's about a 15 to 20 minute guide, so not too much time. And you can have a go with that in a fun educational environment, just playing around to get your head around it and to get sort of introduced to that as well. So would recommend that if you're not familiar. And then we have the last pillar. So we've got logs, we've got metrics, but the issue with these, the biggest drawback for both of these is that they are system scoped. So it makes it really hard to understand anything else other than what's happening within a particular system. So this is where we need things like distributed tracing, because it helps to address this problem of bringing visibility into the lifetime of a request across several systems that might be passing through several different systems, several microservices. So it gives us that wider context, which is super important in distributed applications like those that we just deploy to the cloud. So what is distributed tracing? So really, distributed tracing is a monitoring technique that links the operations and requests between multiple services. It allows developers to trace, hence the name, the path of an end-to-end request as it moves from one service to another, letting us pinpoint errors or performance bottlenecks in those individual services that might be negatively affecting the whole overall system. So as I said, it usually disseminates through a multi-service architecture. We name it distributed because normally these are distributed microservices being deployed into the cloud. Without tracing, it can be really challenging to be able to pinpoint exactly the cause of performance problems in a distributed system. So it helps us to improve the visibility of an application's health and enables very important debugging behavior that can potentially be very difficult to reproduce locally. When it comes to tracing, there are some key concepts to get your head around to be able to actually effectively enable them in your own application. The first of those is this definition of a trace. So a trace represents multiple requests, and usually it consists of multiple spans. So you can see in my diagram here, I've represented that with this orange line at the bottom here, which is consisting of those multiple spans going through sort of multiple different services in this particular application. A span, on the other hand, I should really point out, this is kind of a traces is the end-to-end journey. So it can utilize one or more connected spans, and normally we call it distributed if it connects spans that are performed on multiple services. So you could just have a trace that isn't distributed, but in this case, we're utilizing distributed traces because we're utilizing cloud-native infrastructure where we have distributed macro or microservices. Then we go on to spans. So what are spans? Spans are represented in my diagram here by these pink boxes. A span essentially describes an operation or work taking place on a service. Normally, it's quite a broad definition. So it can, for example, include the operation of a web server responding to a HTTP request, or it can be as granular as a single invocation of a function. So normally, a span contains several pieces of information, so a name, time-related data, log messages, and metadata to really give us information about what's occurring during a particular transaction. So normally it's these spans that are sort of the building bricks, if you like, of the traces. And the key differentiating factor here, this term of context, is why distributed tracing is so important in addition to logs and messages, those other two, and metrics, those other two key pillars. So context is really about, it's an immutable object that's contained within the span data to basically allow us to be able to identify the unique request that each span is a part of. Normally, trace context is typically consisted of two values, and you can see those within my diagram here. So span ID and parent ID, trace ID and parent ID. So the trace ID or trace identifier is the unique identifier that is generated in the root span, and what it's used for is basically to identify the entirety of the trace. This is the same trace identifier we introduced in the last, so basically it's propagated unchanged to every downstream service. So as you can see in my diagram here, it's the same trace ID you can see there in the purple diagram is, I think it's, I'll have to read it on my bigger screen, FEF676. So you can see that is the same one that's used throughout. And essentially that's the unique identifier generated in that root span. Then we have the parent ID or parent identifier. This is the span ID of the parent span that spawned the current operation. A lot of words in that one. basically what it means is what was the service before me, so that I can essentially use these two values together, the trace ID and the parent ID, so that for any operation, it's possible for me to determine the originating root service and to reconstruct all of the parent or ancestor services in order that led to that current operation. And it's this context, this precise ability to be able to pinpoint exactly how my request traveled through those different services and what occurred at each stage, that allows me to be able to identify those bottlenecks and potential issues that might be negatively affecting the whole overall system, but really just be a problem in one particular service or one particular part. So this is why it's really important that we don't just do logs and metrics, but that we also enable tracing as well within our applications to enable that effective observability and to build that effective portal. Okay, so that's more of the theory behind it. How do we actually go about doing this in our own applications? And this is where open source tools and technologies like OpenTelemetry can really help with this. So we're going to take a look at a couple of specifications that you can make use of to enable this in your own Java applications. And these are all going to be open source, so you can all have a go with them afterwards if you would like to. So in the past, the way in which code was instrumented would really vary, because each observability backend would have its own instrumentation libraries and agents for emitting data to the tools. What this meant was that there was no standardization in terms of data format for sending data to an observability backend. And kind of further to this, if a company chose to switch observability backends, it meant they'd have to completely re-instrument their code and configure brand new agents just to be able to emit telemetry data to their new tool of choice. So it was a real load of work. Nothing was standardized. It became quite difficult to be able to effectively enable this in applications. So this is where the community really came together, realized this problem, and decided to come up with sort of specifications that allowed us to really standardize this for our Java applications and for more generically just cloud native applications. And this is where OpenTelemetry was introduced. This was introduced as a joint project between Splunk, Google, Microsoft, Amazon, and many other organizations. So it's backed by some really big players here. And currently, it has the second largest number of contributors in the Cloud Native Computing Foundation, just below Kubernetes. So it really is a project that's getting a lot of interest, a lot of commitment, and a lot of innovation being poured into it. So let's take a closer look at it. So OpenTelemetry originally came from two different sort of projects that had been created already, OpenTracing and OpenCensus. OpenTracing provided a vendor-neutral API for sending telemetry data to an observability backend. But the difficulty with OpenTracing is that it relied on developers to implement their own libraries to meet this specification. On the other hand, we had OpenCensus. OpenCensus provided us with a set of language-specific libraries that developers could use to instrument their code and send it to any one of their supported backends. However, as you can see from the fact that there's two names, this wasn't a single standard. We still had two different libraries, two different projects that we were having to make use of. So in the interest of having one single standard, OpenCensus and OpenTracing were merged to then form OpenTelemetry, or OTEL for short. That happened in May 2019, and it's a CNCF incubating project now, taking the best of both worlds from those original projects. So this OpenTelemetry essentially offers a pluggable architecture that enables us to add technology protocols and formats easily. Supported open source projects include things like the metrics format of Prometheus, and also other trace protocols used, for example, by Jaeger and Zipkin for storing and querying tracing data. It can be used to instrument, generate, collect, and export telemetry data to help you then analyze your software's performance. So really focusing on that first, if we think back to those three steps, that first step, that instrumentation part. So the important thing to note here is that although OpenTelemetry is a fantastic tool and it is a great tool, it is not, and I repeat, it is not a complete end-to-end observability backend. You will still need to make use of other tools and technologies along with it for things like steps 2 and 3, that collection, analyzing, visualizing. So tools like Jaeger, Prometheus, Grafana, Kibana, whatever it might be, you'll need to make use of those along with OpenTelemetry. This is really focusing on step 1, that instrumentation. So how does it look when we take a look at the architecture? it will look a little bit like this. So we've got some microservices up on the top left-hand corner. We've got some infrastructure on the bottom left, and we're sending telemetry data using OTLP to that central collector. OTLP, we just love acronyms in tech, can't get enough of them. This is short for the Open Telemetry Protocol. This is a specification that describes the encoding, the transport, and the delivery mechanism of telemetry data between telemetry sources, intermediate nodes, such as collectors and telemetry backends. So you can see all of those within this diagram here. I mentioned that collector already. What is a collector? A collector is essentially a vendor-agnostic implementation on how to receive, process, and export telemetry data. Normally, it's a single binary that can be deployed as an agent or a gateway. In this case, we're making use of the standard OTel collector that comes as standard with OpenTelemetry. Taking a closer look into actually what happens within that OTel collector, it's this diagram here. And you can check this out with more information in the link below at opentelemetry.io in their docs section. So as I said, this is a vendor-agnostic implementation on how to receive, process, and export telemetry data. Essentially, what it offers is it removes the need to run, operate, and maintain multiple different agents and collectors. So this works with things like improved scalability, and it helps to support those open source observability data formats, things like Jaeger, Prometheus, FluentBit, sending it to either one or more open source or commercial backends, like we saw here, multiple different net ones there that we were using. Now, you might wonder, under what circumstances do I actually need to use a collector to send data? Because you might be thinking, well, why can't I just have each service send directly to the backend? So I would say for trying out and getting started with OpenTelemetry, sending your data directly to a backend is a great way to get value very quickly. In a development or a small scale environment, you can get fairly decent results without using a collector. However, what I would say is that in general, we'd recommend using a collector alongside your services because it allows your service to be able to offload data quickly and allows the collector to take care of additional handling, things like retries, batching, encryption, or even sensitive data filtering. So it allows it to be able to actually deal with all that, and you don't have to place those responsibilities onto your service or have to configure multiple different agents and collectors either. So it can be really handy, especially in sort of enterprise or production environments. So we would recommend making use of it. So that was the OpenTelemetry specification. And something you can use within Java applications is actually the microprofile telemetry API, which makes use of that OpenTelemetry specification. So I've already mentioned microprofile previously, that community-driven specification. And this is a brand new API that was released in the most recent major release of microprofile, which was microprofile 6 just last year. So it adopts some of that OpenTelemetry specification. It actually specifically adopts the OpenTelemetry tracing part of that specification. So it is worth noting here that it does not implement things like OpenTelemetry metrics and OpenTelemetry logging. However, it is hoped that in future, microprofile telemetry will evolve to include these. There are some open issues out there if you want to take a look at GitHub to see how this is progressing, but right now it's just adopting OpenTelemetry tracing. So what this allows us to be able to do is to benefit. So if you're using microprofile already, or if you're using some of the Jakarta EE specification, to be able to benefit from both manual and automatic traces. It's essentially a set of APIs, SDKs, tooling, and integrations. And as I said, designed for the creation and management of telemetry data, just like OpenTelemetry was. Now, there are different ways in which we can instrument microprofile telemetry within our applications, specifically 3. The first of those is automatic instrumentation. So I kind of mentioned already, if you're using Jakarta EE and microprofile, you can already make use of this specification without even making any code changes to gain some tracing information. So if you're utilizing Jakarta RESTful Web Services, that was a mouthful, and microprofile REST client, you can automatically enlist in distributed tracing with the automatic instrumentation. And I'll show that in the demo in just a moment. The second one is manual instrumentation. This can be added via the usual microprofile annotations. So if you're already familiar with some of the microprofile APIs, you'll be familiar with this concept of utilizing annotations to make use of those. The same thing for this API as well. So you can use the annotations with span, or you can do it via CDI injection if you're already making use of CDI with the @inject tracer or @inject span annotations. Or alternatively, you can also use programmatic lookup, so span.current, for example. The third and final instrumentation is agent instrumentation. So you can use OpenTelemetry Java instrumentation project to be able to gather telemetry data without having to make any code modifications. And again, if we don't have time for it in this demo, you can go onto that yourselves in the guide if you are interested in that instrumentation for this API. So taking a look at how this works in an application, we've got a couple of microservices here. In this case, they're running on OpenLiberty, which I'll go on to in just a moment. But essentially, we've got some requests coming in. We're gaining context by tracing those requests through the multiple services, and we're able to feed that information back via the backend exporter. However, you may be orchestrating that. So in this case, you can utilize different services or different tools and technologies. In our example, we're going to be making use of Jaeger, but it's really up to you as to which one you want to use. But essentially, with microtelemetry installed, we're able to have the request go through, responses generate spans, and the paths between the services are monitored using their context. So it allows us to gain this really effective observability into our distributed cloud-native application. So that's the theory. Now time for some practical, because we all love to see live coding. So let's get onto it. For this, we're going to be utilizing OpenLiberty. I've mentioned this several times throughout this presentation. I'm wearing a t-shirt that has it all over. So you can see I love this project. This is an open source cloud native runtime. It really allows developers, the idea is that developers can just focus on their code. They're able to utilize things like dev mode, which we'll show in the demo. Dev mode allows you to be able to make very fast, iterative changes in an agile manner by having essentially a hot reload function. So instead of having to tear down your application and restart it, you can essentially just leave your server running, and it will automatically listen out for code and configuration changes and just update or redeploy the particular classes that you've changed. So it makes it really easy to be able to see those changes as and when you're sort of developing in that initial development stage. It also makes it easy to write tests. We've got lots of integration with different testing frameworks, including things like test containers, to enable you to have that true to production testing in container environments. And not in your way tools and flexibilities, we've got IDE integration plugins that allow you to be able to do this all within the IDE. So if you want to find out more about this open source tool, then do check out the article link at the bottom here. I helped write it, so I'd love if you check it out, and hopefully it'll give you more of an idea of what this is all about. Within this, we have an open source website, and on that we have open source guides and tutorials. So these guides and tutorials I've mentioned before, we've got them on most of, or pretty much all of the microprofile and Jakarta EE APIs. So if any of them catch your interest and you want to learn more about them, then please do check out our website and go to the guide section. You'll find them all there. The one that we're going to be utilizing today is within our observability section, and it's the second one in on the top there, enabling distributed tracing in a microservices with OpenTelemetry and Jaeger. Now you'll notice some of the ones on my screenshot here have this button, this sort of tag, running cloud. What that means is that you don't have to do it locally on your own machine if you don't want to, which is kind of nice. So if you've got a lockdown machine and you can't install dependencies, then it's nice to be able to utilize our cloud native environment, which is what I'm going to be showcasing in the demo today. This is all based on essentially a very similar tool to Thea, where we enable you to have a full IDE, terminal and instructions all within one browser. So all you need is a browser on your machine to be able to get started having a go with these interactive tutorials. So without further ado, I'm going to switch over to this slide, and I'm going to just check that you guys can see this. Please let me know if the font is too small. I'm trying to do my best with sort of a balance between being able to see everything on the page and also font size as well. So to get here, we can see perfect. Thank you. Thanks for those comments. So the way I got here was essentially going to the OpenLiberty website. We've got a menu on the left-hand side, or you can search for them if you know what you want to search for. For this, I went to the observability section, and as I said, that second one in is the one I'm doing, and I'm going to run it in cloud. When I go onto it, it will show a page like this, and that run in cloud button is on the right. Now, if you don't want to run in cloud, totally fine. You can also run this locally. but you will need the prerequisites that are listed at the top of the screen there. We do that for every guide, and they do change depending on the guide or the tutorial you're doing. You will need to sort of log in for this. We didn't have a login before, and then Bitcoin miners find us. So now we need a login, unfortunately, but we do have lots of different logins available, including lots of social logins, or you can do it with your email. The one I've used is GitHub. Hopefully, as developers, a lot of you will already have GitHub. So it should be fairly easy to go on and sort of enter into this environment. You should get an IDE on the right-hand side. If you don't get a terminal appear automatically, then you'll need to go to Terminal, New Terminal, and that will open up a new terminal here at the bottom. It will start with introducing what this guide is going to be showing you. I've already kind of explained that, so I'm just going to skip this step. And it will also give you a bit of information about sort of the application we're using. We use the same application for all of our guides to make it very easy for you to go from one guide to the other without having to understand the concept or the sort of what's behind it in the application, because you're already familiar with it. So the way that this works is it's a very simple application. It's got 2 microservices. It's got one microservice called System, and that is essentially scraping your system data every 15 seconds. And then we've got the inventory microservice, which keeps a list of all of that system data. So fairly simple, because we wanted to keep it simple so you can just focus on learning the technology. So as I said, we're going to be utilizing OpenTelemetry tracing through microprofile tracing in this application to be able to understand how those requests are disseminating through the services in our application to give us greater detail, greater context on what's going on so that we can understand our applications better in this environment. So for this, I've already cloned the repo. As I mentioned, all of this is open source. So if you do want to check it out, head on over to our GitHub page and you'll be able to see these guides there. You'll be able to see the directory structure in project view. So if I make that a bit bigger, hopefully you can see this. So the way that all of our projects are sort of set up is we have a start and a finish directory. Start, as the name suggests, is where you're going to start. It's the sort of half-finished version, and you're going to go through the steps of this tutorial to be able to get it to that finished product. Finish is essentially where you should end up. So if, for example, you don't want to go through all the steps and you just want to go straight to the finish directory, you can. In fact, a lot of the guides do encourage you to try what you'll build before you build it. And it tells you some steps of going to that finish directory and sort of giving it a go before you proceed with the instructions. In this case, I'm going to skip that step and go straight to the start directory so that we can have a go and see what we need to change in our application to actually enable observability. If you do ever get stuck, do feel free to go and revisit that finish directory to see where maybe a bug's been introduced or where yours differs. Now, what I've done already is, in the interest of time, I've already got my microservices up and running. So the way that I did that is with this Maven Liberty. Oh, can you see that? I'm going to copy and paste it just so you can see it into another terminal. So essentially, it's this Maven Liberty command, Maven Liberty dev. You could use Maven Liberty run, but what this command enables us to do is start it in that dev mode that I mentioned that allows us to be able to have that hot reload capability. So the ability to be able to very dynamically see those code changes as we sort of enable them in our application. So I've enabled both of my applications, system and inventory. I'm just going to make this a bit bigger so you can see. To start in dev mode, you'll know that they're up and running in dev mode when you see this message, this line of stars, and this message, Liberty is running in dev mode. So that's when you know you're all ready to go and can continue. So what I've done is gone straight to this part of the instructions where we actually start enabling telemetry, just giving you a bit of info on what I've already set up here. So because I've got those 2 microservices running in dev mode, they are essentially taking over those terminals. So I need to open up a new terminal to be able to do any other commands I want to do. So in this case, we're inside the start directory as I've been told to do. And what we're going to do is we're going to replace the server.xml file to be able to actually enable the microprofile feature that we need. So I'm just going to make this smaller so you can see the file again. So in this, we've got the server.xml, and I'm just going to copy and paste the code that's given to me here into this file in the interest of time. If you wanted to, you could go into that, take a look at what the difference is, and manually change that yourself. We've tried to make this as easy as possible by adding in these interactive buttons. So we've got the copy button, and then for any, I'll have to scroll down for it. For any commands you need, we've also got an execute button that will execute it straight into your terminal just to make this as easy as possible. So going back up, Essentially, what we've done here is enable the microprofile feature in our application in the server.xml file. In this case, I've done it in the system service, but I'll also need to do it in the inventory service. So I'm just going to open up that other server.xml file, this time for inventory, copy and paste in, and you'll see that new feature, microprofile telemetry, being introduced here. Now, kind of weirdly, at least I find it weird, microprofile telemetry tracing is by default off. So we actually need to be able to enable tracing elements, we have to specify that the OTel properties in the microprofile file is sort of turned on, essentially. So what we need to do first is create a microprofile config properties file. To do that, I've got this touch command, so I'm just going to execute that in my terminal, and now I can just go ahead and open that up. If you don't want to use these buttons, we do also provide you with the file directory path if you want to go and manually find it yourself through the Explorer view. There are two different configurations I'll need to put into here. So essentially what we're doing here is utilizing another microprofile API to allow us to have external configuration to our code, which is super helpful in distributed cloud native environments. So in this case, I'm just naming which service this applies to. In this case, it's the system. And this is the key property we need to add, which allows us to be able to essentially turn tracing on. And that's setting this OTel disabled to false so that we can actually use OpenTelemetry tracing. Now I need to do the same thing for the inventory microservice. So I'm just going to create that file, open it up. You'll see it's empty because I've just made it. And I'm going to copy and paste in these details here. So you can see the only change really is the name because we're doing this to a different service this time. This time it's the inventory microservice. But you'll see we're using the same property of disabling OTel being disabled. So enabling OpenTelemetry tracing. So now that we've enabled it in both the server.xml and we've got this config properties file set up with this correct configuration, we can now make use of that automatic instrumentation. So what I'm going to do is I'm going to run this curl command just to make sure that the system and inventory services are running correctly. And I've already used a Docker command, which was earlier on in the instructions, to be able to get Jaeger up and running in the background so it was ready for me. So I've already got a tab open for that. So I'm just going to refresh this. And what I should see is I now have, perfect, I've got my services up here. So if I select inventory, for example, and look at find traces, you can see I've now got 3 spans as part of this trace. And I can actually dig into, get more information about this and sort of what's going on within this trace as well. So getting additional information. And you'll see that I got that without even making any code changes, just using that automatic instrumentation because I was already using RESTful from Jakarta and microprofile REST client from microprofile. So if you're already making use of those, you can already get the fact that there are already 2 spans in this particular application. It sort of automatically gets some benefits from it already. Now, the next thing I wanted to show was sort of enabling explicit distributed tracing. So as I mentioned, automatic instrumentation only instruments your application with Jakarta RESTful web services and microprofile REST clients. To be able to get further spans on other operations, for example, or if you're not using those specifications, so things like database calls, you can add that manual instrumentation to the source code. So to be able to do that, we need to enable all REST. So the microprofile telemetry feature has been enabled to trace all REST endpoints by default in that previous section. So now we're going to utilize these annotations that I mentioned in the presentation. So @with span annotation. And we can also use CDI injection to be able to inject a tracer object where we can also create and customize spans. So let's take a look at some of those in the time we have left. So the first thing I need to do is replace my pom.xml Maven project file of the inventory service. So this is inventory first. So let's go and take a look at that. Now, all of our guides make use of Maven, but that's not to say you can't use another build tool. You can go and utilize Gradle, or if you really want to, Ant with OpenLiberty. We just keep it all as Maven to keep it consistent. So again, you don't have to worry about a new build tool or different build tools between different guides. So in this case, we're just making use of Maven as an example. So I'm just going to scroll down and copy and paste the sort of stuff I need for this pom.xml. Again, this IDE does not automatically save. So do make sure that you are saving as you go along. And that's, if I go back to the other terminals, you'll see that it's going to start. I'm going to make this bigger so you can see it. Oh, whoops, didn't mean to do that. Go back. I'm just going to make this bigger. So now you can see that actually it has been updating as we've been making these changes. So I didn't have to tear down and restart my whole application. It's automatically been doing that, pulling in the changed classes and configuration for me automatically. So it's a great help that way. I've now marked up the order of this. Perfect. There we go. Okay, so in this changed pom.xml, what you'll see if I scroll further up is that we are essentially providing the OpenTelemetry API and OpenTelemetry instrumentation annotations in our build path. So we now have 2 IO OpenTelemetry dependencies, which should be slightly further down. So we've got some Jakarta, my profile, here we go, OpenTelemetry. So we have the OpenTelemetry dependency and the instrumentation dependency from OpenTelemetry as well. So if we go back to our server.xml for the inventory service, so let's take a look at this. And we need to add in some additional stuff to this as well. So let's copy and paste over and remember to save. So in this, OpenTelemetry APIs are exposed as third-party APIs in OpenLiberty. So to add the visibility of OpenTelemetry APIs to the application, we need to add third-party to the types of API packages that this class loader supports. So instead of explicitly configuring a list of API packages, we can just set the plus third-party value to the API type visibility. So here we go. Yep. So you can see there, I've added that into my server.xml specifically for the inventory service here. So this adds, this configuration essentially adds third party to the default list of API package types that are supported within our application. So utilizing tracing with Jakarta CDI beans. So we can trace our Jakarta CDI beans by annotating their methods with the @span annotation. So we're going to replace our inventory manager class. This is one of the classes we're using within this particular microservice. So if I scroll down and copy and paste this, I will showcase some of the annotations we have in here. So there you can see the @with span annotation. We've done that to both the list and the add methods. They've been annotated with this. What it means is they can accept an additional parameter that functions as a span name. So in this example, the default span name assigned to the list method here is automatically generated through the instrumentation. We can also specify a custom span name. So for example, here we're specifying a custom span name in the add sort of annotation here, the method here. So for example, we specified it in the add method. The OpenTelemetry instrumentation provides a new span for each method. So now we can collect and trace the spans across different services. We can optionally add additional parameters depending on what we want. So things like the span attribute, which allows us to be able to specify host name, for example. We've done that as well in here. If I go over, I've lost it now. We did do it in the add. I'm being blind. Span attribute. There we go. So you can see we've specified that additional parameter in here, just to give you an example of what else you could also add. You can take a look at the documentation to see more about the annotations that you can make use of to be able to actually instrument this code. Okay, so without further ado, just in the interest of time, because I really want to show you guys this, let's run that curl command, revisit our Jaeger UI. Let's refresh this. Sorry, go back to the home page, inventory, find traces. So now you can see we have an additional trace here that's made up of 2 spans. And we can go into that and find out that additional information that we had, that we've added in through that manual instrumentation. So now we've got both automatic instrumentation and manual instrumentation using those annotations through microprofile telemetry, really enabling that effective observability in our application. Now, in the interest of time, I'm not going to go through the rest of this guide, but if you do want to take a look at it, then I would really recommend you do and go through the additional steps in this guide, showing you more about those additional techniques to be able to instrument this, including things like using the agent instrumentation as well. When you get to the very end of this guide, it will get you to run the tests that we have within our application. We've already configured those for you. And then at the very end, it will ask you to stop your Jaeger service and to clean up your environment. Now, it's really important that you do clean up your environment using our scripts, because if you don't, if you then go on to another guide, it will have already had all of that sort of progress, all of the scripts that are running, anything that's up and running, anything that you've cloned from a repo will automatically be there because it saves your progress. Now, if you don't or you forget to clean up your environment, you can log out and log back in, and that will automatically refresh that for you. But it's just easier to make sure you're following all the instructions and clean up if you want to go on to another guide afterwards. So hopefully I've showcased just how easy it can be with a few steps by editing things like our server.xml, our pom.xml, adding in those annotations, making sure we have the right dependencies within each of our sort of applications or microservices to be able to add in those spans and those traces to really gain that contextual information as our requests pass through multiple microservices, enabling that effective portal to give us that effective observability. So with that, I'm just going to wrap up because I know we're coming close to time now. So hopefully through this presentation, what I've showcased is that we are entering a world of increased complexity. But the nice thing is that, through effective observability, we can enable that critical monitoring and understanding of how our applications are behaving and performing in what can be quite a convoluted and complex environment of being cloud native. Now, I'm not expecting you to go and implement this all by yourselves. As I've shown you, there are open source communities out there, open source tools that they're developing that enable you to be able to look through that looking glass to build that effective portal, to be able to sort of understand your application better and gain that effective observability, including new standards like OpenTelemetry and open source Java tools like MicroProfile that enable us to be able to use this in our own applications. If you are interested in learning more on this topic, and I really hope you are after this presentation, do check out some of these links. I've got a general recap of what is observability and some blogs here on how to enable it with MicroProfile in your own application, both a blog there and an article on IBM Developer on why you might want to do this as well. If you are interested in learning more about OpenLiberty from what I've shown here, please do follow us and connect with us on social media. I run these accounts, so I'll definitely say hi if you come and follow us. I'd really appreciate it. Or if you just have some feedback on if you've used OpenLiberty and have feedback, or if you want to have a go with the guides and you want to tell us how you found them, we would really appreciate that too. We spent a lot of time on those guides, super proud of them, so hopefully you enjoy them and get some use out of them. But please do connect with us here if you do want to sort of interact with us and find out more about what we're producing. And with that, I'm going to say thank you so much for sticking with me for this whole session, for spending your time learning here at the J Champions Conference, and for being such a great audience. I really appreciate your time. If I didn't get around to your questions, or if I don't get around to them in a minute, then please do message me on social media. Again, as I mentioned, LinkedIn or Twitter X is where you can find me, and these are the links that you need. Yeah, really appreciate your time today. Thank you so much, guys.
Hey, Grace, that's great. So we do have lots of thank you here from Sebastian. Thank you. Great talk. Actually, Eric, great talk. And Sebastian says, thank you, Grace, for hands-on session, introducing your tutorial sites. Lots and lots of thank you here.
I appreciate it, guys.
So let me just put so Eric, and then Gary says, thank you for your presentation. And
it's always nice to hear that you guys have enjoyed it. So thanks for the comments and making this a lot more interactive. It can often be challenging when it's a virtual conference. So it's really nice to get that feedback from you guys and questions and interactions. So thank you for not just being a blank screen that I talk at. It's nice to get that two-way dialogue going.
Right. So there's one question here. So yep. John says, could you get the link directly here in the chat? So
yes, let me grab them. Did you want the link to the general guides page? Is that what you were interested in?
So, and I think you might need to send on the private chats so I can send to everyone, Grace.
Yep. So that's the link to the guides, and that's the page that I showed where you can go through the categories and select the one that interests you. If you're interested in this guide, you want to go to the observability section. Which I can send in a separate link. I'll send you a link directly to the guide that we did in this demo today, in case you are specifically interested in that. Okay. But we do have a bunch of other open observability guides in there as well. So if you want to find out more about Jaeger or Zipkin, for example, then do check them out. I'm also working with the guys over at Digma to work on an article on how you could connect with that as well. So yeah, we're always looking at new integrations, new connections to be able to sort of publish about. So keep your eye on our blog where we publish all that information.
Okay, yeah. So John says the live tutorial that you were doing, right? So
yep.
that's
the second link. Yeah.
Cool. All right. So yeah, so guys, you have that. That's good because then it becomes here in the chat, so anyone that's watching later can have access to this easily. Now, I think there's just one quick comment here in the very beginning when you talk about observability. So Vincent says, like a doctor that checks your body signals to understand sickness, right?
Yes, absolutely. I love it when people make biology analogies because it just so connects with me. That is exactly what it's like. I've made connections before between, security is just like the bodily defenses we have with like injections and the way our body has, limited openings into it. There are so many analogies you can make between biology and software, and there's so many ways in which we can learn from Mother Nature. It's had millennia to evolve and become so effective. So I do love it when we make these kind of correlations between the two. So yes, it's just like a doctor checking bodily signals. A doctor isn't able to always see exactly what's going on inside of us, but what they can do is monitor those trends, monitor those external outputs, like I was saying in that definition, to be able to understand from those external outputs what's going on in that complex, because the body is complex, that complex internal system. So it is exactly like that, Vincent. I love that. I love that Chris came up with that as a great analogy. Definitely one to keep in mind when you're trying to enable effective observability in your application.
Okay, that's awesome. All right, so thanks a lot, Vincent, from saying that. And I don't see any more questions here, Grace. So Jasper saying, see some of you in JFocus. Are you going to be in JFocus?
I won't be, sadly, but I'm hoping to try and catch some of the sessions when they're recorded.
Yeah, I'm not going to be there either. So enjoy JFocus. Jasper is going to be a great conference. Okay, guys. So everyone, thanks very much for being here. Grace, thanks a lot. It was awesome to have you here at the Java Champions Conference. And everyone else, all the talks are being recorded, and you can watch all of them in the same link that you watched them before. And there's other talks starting right now. So thanks so much. Thanks, everyone.
Thanks, guys.